Hello, you are welcome to session 2 of Unit 6. Here, you are going to be introduced to a more advanced explanation of consumer behavior and equilibrium. The concept of indifference curve is central and very important to the consideration of the indifference theory of consumer behavior. In this session, therefore, you will learn about indifference curves and their characteristics. You will surely be fascinated by the geometrical concept that we are going to talk about. By the end of the session, we believe that you should be able to define the concept of the indifference curve and should be able to state four characteristics of the indifference curve and explain the meaning of indifference maps. It's going to be very simple. We are going to talk with diagrams and also talk to the diagrams. Stay with me through the session and I believe it's going to be an enjoying one. Let's talk about the concept of indifference curves. Now, imagine a consumer who has only two commodities X and Y in his budget. So, imagine yourself, you have only two commodities X and Y in your budget. Now, suppose a household is consuming a combination of X and Y. I'm going to draw up a diagram where you can see these points that I'm talking about. So, let me draw. First, I'll draw two diagrams. I'll be speaking to each of the diagrams. I'll name this diagram A, right? Capital A. Let me use capital A. Let me clean it and write capital A. I'll draw another diagram here. I'll talk to each of them. So pay attention when we are talking to them. I'll name this capital B. But I know that this is Y and this is for commodity word X. Alright. Now let me draw some indifference curve here. I'm going to have some M, P, Q, and some S. I'll relate this to some point here, this to some point here. This will also have its respective point. This will also have a point. Okay, I'll make it 2, 4, 6, 8, 0. I'll make this rather 3, 4, 6, and I'll make this 9. Now let's look at the first diagram also for commodity Y and commodity what X. This one I'll just draw something like a cross or additional sign. I'll make this I, this will be I, this will be I, then this will be I. We're going to talk about quadrants. Remember quadrants from SHS. I'll name this small a, this will be small b. Alright, I'll name the center of this diagram P. Okay, now let's talk to the diagrams. So the first diagram is commodity XY commodity space. Diagram A. This is the first diagram. Well, let me even write first. Let me give this what second diagram. Okay. So we can see, or suppose a household is consuming combination of X and Y at points P on the first diagram. That is OA of Y and OB of what? X, and which to determine the combinations that might give the same level of satisfaction. So clearly, combination of X and Y in the first quadrant, that is quadrant I, contain more of both what X and Y. At this part we have more of what X and Y, and then consumers will be better off. Similarly, combination of X and Y in quadrant I contain less of what both X and Y. So less of both X and Y. None is higher than the other here. And here consumers may be worse off. For the second quadrant, that is II, it contains combination of more Y and less of what? X, as you can see. And for that of quadrant IV, it contains more of X and less of what? Y. Combinations in these two quadrants have the potential of giving the same level of satisfaction. Now, let's look at the next diagram, that is the second diagram, or diagram B. Let us assume a consumer at M on the diagram. The diagram I have points M, P, Q, S. Let's assume a consumer at point M, that is 9 units of Y and 2 units of what? X. or points P, 6 units of y and 4 units of x, or Q, 4 units of y and 6 units of x, or say S, 3 units of y and 8 units of x, in the figure we have shown below here. Now we will have the same level of satisfaction because they are all on the same indifference curve. The consumer is indifferent between the combinations, and so we have drawn a line through this point which traces the locus of the various combination, that is of combination x and y, of equivalent utility to the consumer, and the line is what we call the indifference curve. So this line that we have drawn to connect the point is what we call the indifference curve. The indifference curves to the east of MPQS will be higher in other indifference curves because they will contain either the same amount of commodity and more of the other, or both of x and y. But indifference curve southwest of the line MPQS will be lower in other indifference curves, yielding less satisfaction. Since so we are talking about not what we've mentioned, not what did I say? Oh, you've forgotten. We said northeast, and we have made mention of what? We made mention of south what? Are you sure? Southwest. Okay. You are correct if you say southwest. Those of you who are saying other things, please make sure you pay attention. Now, so the indifference curve southwest of MPQS will be lower in other indifference curves, yielding less satisfaction since each bundle will contain either less of one commodity or less of both commodity X and Y. If you want to understand the northeast and southwest, you can compare it to the diagram we had with the quadrants I, that is the first diagram. An indifference curve is a graphical representation of a consumer's taste and preferences. That is, an indifference curve is a locus of points in the commodity space. The commodity space, we said the first diagram is the commodity space. So the indifference curve is a locus of points in the commodity space. So we can see that in the second diagram, we had points P, point M, point Q, point S. So we are looking at points in the commodity space that represent combination of goods. So you can see that M combines good what X and good Y. So 2 units of X, 9 units of Y, or we say 9 units of Y, 2 units of X. So it combines goods that give the same level of utility or satisfaction to the consumer or to which he is indifferent about. Let's now talk about the characteristics of the indifference curve. We may refer to some diagrams, but do not be confused. It's going to be very simple. So before we started, we said that by the end of the session, you should know at least 4 characteristics. And here you can see we have listed 4 points here. Several characteristics of indifference curves are very important, but here we want to consider 4 basic characteristics of the indifference curves. We are going to talk about indifference curves being downward sloping, that is a negative relationship. Indifference curves being convex to the origin, indifference curves being not intersecting, and indifference curve, that is density of indifference curves. I will take my time to explain each of them. Now let me talk about indifference curves being downward slope. Indifference curve have a negative slope, that is the slope downwards from left to right, because more of one product means less of the other. We can see from the previous slide we just moved to this slide. The previous slide we were talking about the 2 graphs where we had the first graph and the second graph. The second graph gave us the indifference curve, and we could see that it was what downward sloping. It moved from the left to the right. So consumption of whereby we had more of y, we had less of x, and whereby we had more of x, we had less of what y. And so we say that the total utility remain unchanged, although there is more of this and less of that. That more of this and less of that depicts a negative relationship between the two. So no 2 positions on an indifference curve actually contain same bundle of goods. It is only possible to remain on the same indifference curve if additional units of the other compensate for the loss of one commodity. And A movement on the indifference curve actually involves either an increase in y or a decrease in x, that is moving to the left. Or we can look at increase in x as y decreases, that is when we want to move to the right. So a movement from one position to another position on the same indifference scale would be possible if and only if the loss of one commodity was fully compensated for by the gain of the other commodity. The loss we are saying this, as this was decreasing, that other was what's increasing, so the other gained. That's what we are saying. Now, how about the indifference case being convex to the origin? Now, you can refer back to the diagrams that we had, and you realize that the shape was like it was like this. Let me draw something here. You see, this is x, this is y, this was this. Look at it. Now, as viewed from the origin, a downward sloping curve can be concave, that is bowed outward, or convex, bowed inward. Do you know that a concave curve has an increasing sloping as one moves down the curve, while a convex curve has a diminishing sloping as one moves down it? Maybe do not worry if you actually don't know, but you will get to know as we keep on going through the slide. Now, note that in the figure or the diagram we drew with the points P, M, P, Q, S, you can refer to that. Just pause this one and can just go back to that slide in this very session. Look at the diagram again and then come back to this to listen to what I'm saying. Okay. So realize that the indifference curve is convex, like I've drawn here, from the origin. Each slope becomes flatter as we move from point M to P to S and so on. Let me intentionally even bring M, P, Q on this one. So let me say M, P, Q, S. Okay. Technically, the slope of the indifference curve at each point measures the marginal rate of substitution of the combinations represented by that point. The slope, or say the marginal rate of substitution, shows the rate at which the consumer who possesses that combination will substitute one good for the other good to remain equally satisfied. And the diminishing slope of the indifference curve means the unwillingness to substitute x for y diminishes as one moves down to the curve. Referring back to that diagram again that had this point M, P, Q, S, you realize that beginning at point M, we want to begin at point M. Now here, in relative terms, the consumer has a substantial amount of y and a very little amount of x. Let me even intentionally sketch something here. See, to Q that S was reducing. 2, 4, 6, 8, and this was what? On the Y we had 3, 4, 6, right? 3, 4, 6, and 9. Okay, now let's talk so that you understand more. So here in relative terms, you see that the consumer has a substantial amount of y and very little of x. Talking about point M, the consumer has 9 on y but 2 on what x. So the consumer will then be willing to give up a substantial amount of y to get more of x. In this case, the consumer is willing to forgo say 3 units of y to get 2 more units of x. We are talking about the ratio. So the MR is going to be something like say 3 3 over 2 or 3 to 2. In a move from point P to point Q, the consumer is willing to give up only 2 units of Y to get 2 more units of X from point P to point Q. Because from point P is 6 units of Y, 4 units of X, and then point Q is 6 units of X and rather what 4 units of Y. So we can see 2 difference. So the consumer will give up 2 difference on the Y and in order to get what 2 more units on the what X. Alright, so the MRS is going to be like 2 over 2, which the 2 over 2 will cancel so that we have 1. Having less of Y and more of X at point Q, the consumer is willing to give only 1 unit of Y in return for 2 more units of what X. And the MRS will now fall to 1 over 2. It will now fall to 1 over 2. Now, in general, the more of a good a consumer already possesses, the lower its marginal valuation to him. Therefore, as the consumer acquires more and more of X, smaller and smaller quantities of Y will be sacrificed. What are we talking about? We are talking about point 2. Indifference curves are converse from the origin. Now, the marginal rate of substitution diminishes as the consumer moves downward along the same curve and is referred to as the marginal rate of what? Substitution. Let's talk about the third point, that is indifference curves are non-intersecting. Indifference curves cannot intersect. This follows logically from the transitivity of preferences. That is, we say if A, B, and C are different combinations of two goods, then whenever A is preferred to B, B is preferred to C, then A is also preferred to C. Let me write something like this. If A is preferred, let me use this, preferred to B, and B is also preferred to C. You like A more than B, but you like B more than C. So eventually you're going to like A more than what? C. True or false? That's what we call the law of what? Transitivity. We may prove this characterized by the reductio ad absurdum method. Reductio ad absurdum. And we assume two indifferent curves can intersect and then show that this assumption leads to an absurd conclusion. Let me try and sketch a situation where two indifferent curves are intersecting. Now let's look at this. Here is y, here is x, right? Okay, this is my origin. I will intentionally sketch this and say I'll sketch this too. I'll make this I, I'll make this I. Okay, I'll say here is R, and I'll say here is P, here will be P. I'll make this say T, where they intersect T. I'll make this Q, I'll make this S. Okay, so now let's look at this diagram. Two indifference curves I and I have been drawn to intersect at T in this diagram. Let P be vertically above R as shown here, and S be vertically above Q. S be vertically above Q. And P must be preferred to R because it contains more of Y and no less than X than R. P and T are indifferent. They are on the same indifference curve. Therefore, T must be preferred to R. Since P is preferred to what? R. So it logically follows that at any point on the indifference curve, I must be preferred to any point on the indifference curve, II. But since S on II is preferred to Q on I, these two logical inconsistencies arise. We are going to talk about inconsistencies that will arise. Since P is preferred to R, Q must be then preferred to what? S, because P and Q are on the same indifference curve. And R and S are what? On the same indifference curve. But see, since P is preferred to R, and then Q should also be what? Preferred to R. But in this case, S is rather preferred to what? Q. So it's bringing inconsistencies. And also, since P is preferred to R, T must be preferred to R, but T is also equal to what? R, because they are also on the same what? Indifference curve in terms of level of satisfaction. They lie on the same indifference curve. So clearly, indifference curve cannot cross or intersect each other. So this diagram should never hold. So that's what we are saying for the third characteristic. Indifference curves are what? Non-intersecting. Let's talk about the last point, that is the indifference curve, the density of the indifference. Now, since indifference curves pass through each point in a commodity space, if you've forgotten about commodity space, go to where we drew two diagrams. The commodity space was where we talked about quadrants I, and IV. So since indifference curve pass through each point in the commodity space, an indifference map will have an infinite number of indifference curves. Technically, we say indifference curves are everywhere dense. This actually simply means that if we draw two indifference curves, we should understand that an infinite number of indifference curves lie between them. We can have several combinations. So we assume what infinite number of indifference curves lying between them. Okay, so it is everywhere dense. This brings us to the end of this session. The next session, session 3, will talk about the budget line. And so until then, I will say thank you.